Hi everyone. Think about the last time you bought a new phone, pair of sneakers, or even ordered food from DoorDash. What make you choose it? Chances are it's not just about price. It was because the product worked the way you expected, looked good, or maybe even offered something new or exciting you haven't been seen before. That mix of reliability and creativity doesn't happen by accident. It's a result of quality and innovation working hand in hand in product and process design. In this topic, we are going to explore how companies balance consistency with fresh ideas to create products and services that keep us coming back. Here is our roadmap for today. We'll begin by understanding what quality in design really means. Then we'll explore the Kano model, a simple but powerful way to understand what customers really want. Next, we'll look at the product design process and see how quality function deployment, or QFD, helps translate customer desires into actual designs. We'll cover strategies like design for manufacturing and tools like the FMEA to prevent failures. Finally, we'll wrap up with the green design principles, ensuring our designs are sustainable. By the end, we'll see how all these pieces fit together to create great products. Quality is not just about avoiding mistakes. It's about preventing disasters and making customers happy. Imagine a pacemaker that fails or a plane engine that stops mid-flight. The consequences are catastrophic, both in terms of safety and cost. The key idea here is that quality starts at the design stage. It's much easier to design product right from the beginning than to fix problems later. So when designing, ask yourself, what do customers really want? What can we deliver with the resources and technology we have? And importantly, how much will it cost? And how much are customers willing to pay? Think about your own favorite gadgets. Why do you choose one smartphone over another? David Gavin identifies several dimensions of product quality. The first one is performance, which means how well the product performs its primary function. For example, a laptop should run software quickly without overheating. And the other dimension includes durability. And to take myself, for example, I always buy cast iron cookingware instead of the non-stick pan because cast iron can last for a very long time. And appearance, which is why we often choose clothes or shoes that look stylish, and reliability, which ensure your product doesn't fail unexpectedly. Remember, quality is not just one thing. It's a mix of factors that together make the product valuable to the customer. The Kano model, a simple framework to understand what delights customers. Basic quality is what customers expect. A car must start. If it doesn't, the customer won't happy. But if it starts, the customer don't cheer either. Performance quality improves satisfaction. The more you as a customer have it, you are more satisfied. Longer battery life or faster internet speeds are those examples. Exciting quality is unexpected feature that wow people. Think of a phone that automatically sorts your photos, or a video game that has hidden Easter eggs. Now think about your favorite product. What makes this special? It's often the exciting quality. Designing a product is not random. It's a process with interrelated stages. It starts with the generating product ideas. This could be a new app, a kitchen gadget, or wearable device. Then we project customer needs, figuring out what people really want. Then we consider technology feasibility. Can we actually make it with available technology? We also select process technology, meaning how it will be manufactured. And finally, define the product fully, including drawing and specifications. This ensures everyone is on the same page before we start building. After defining the product, we move into later stages. This includes designing the marketing plan to reach the target customers, evaluating the product through testing, planning the manufacturing system, and then finally producing and delivering the product. And remember, project management is key. We need to stay on budget and on schedule. Think of it like managing a group of projects. We need clear roles among the team members, milestones, and checks to ensure success. Where do product ideas come from? It can be internal, such as R&D, marketing, management, or employee suggestions. And it could be also from external sources, such as from our customer, our suppliers, or even our competitors. Some products are R&D driven, such as iPhone 2007, which was revolutionary. And other are marketing driven, which mean created to meet clear customer demand. One example is the Nike's Air Jordan sneaker. Defining the product meaning finalizing drawing, specification, and descriptions. So think of it as creating the blueprint before building a house. Quality function deployment, short as QFD, is a tool to turn customer desires into actionable design specifications. Developed in Japan by Dr. S. Mizuno, it uses a matrix called the House of Quality, which is a comprehensive matrix visually linking what the customer wants to how the company will meet those wants. It ensures that we don't just guess what people want. We design for it in a systematical way. Let's talk about how to use QFD tool. The step one is to gather customer needs, also called the voice of customer. This need to be measurable. For example, a restaurant customer might want clean facilities, comfortable seating, delicious food, and responsive servers. We can structure those needs hierarchically so we know which are critical and which are nice to have. Now take a moment to think. What were your top 3 needs if you were reviewing a restaurant? Next, we translate customer needs into technical requirements, such as tile type for the clean facility and server training. Then we analyze the relationship between those needs and technical solutions. We use symbols to indicate strengths. So the dot means strong, and numerically it's 9. And the circle means moderate, and it's numerically is 3. And triangle means weak, it's 1. And we also look at how technical requirements interact. This is the roof of the house of quality, helping us identify conflicts or synergies. Step 4 is to evaluate the competition. How does our product measure up to others? Customers rate features on a scale, and we also compare technical capabilities. This identifies strengths and weaknesses and inform design priorities in steps 6 and 7. So after accessing customer needs and technical requirements, we prioritize. We calculate weights for each technical requirement using customer importance, target value, and sales impact. These weights guide designers to focus on the features that matter most. So it's something like you choosing which homework problem to be tackled first, based on their points and difficulties. QFD is not just a single matrix. It can be cascaded across multiple levels, such as customer attributes to technical requirements. This is the initial house. Then we have the technical requirements to component attributes, and component attributes to the process operations, and process operation to key process variables. So the benefit of doing multi-level QFD is the standardization of parts, simplifies inventory, and keep complex products under control. Think of like the breaking a big Lego set into a smaller, manageable sections. Design for manufacturability means we design product for easy and cost-effective manufacturing, so few parts, modular design, and easy assembly. For example, many BMW and Volkswagen cars, they share many common parts. And concurrent engineering means have team working together simultaneously, reduce the time to market, and improve communication. And think of a group project where everyone contributes at once. So it will improve the communication and increase the productivity. Failure mode and effects analysis, short as FMEA, is a systematic approach to identify, analyze, and document potential failures in a product or process. So the purpose is to predict and prevent failure before they occur. And the goal here is to improve product reliability, safety, and performance. And the key benefit of using FMEA is to reduce costly failure and recalls, enhance customer satisfaction and confidence of our products, and guide proactive design and process improvement. Several steps involved in using FMEA tools, and those steps are simple but very powerful. The first step is to identify functions, potential failure modes, and their effects. And second is to rate severity, occurrence, and detectability. And then we calculated the risk priority number, RPN, to focus on the most critical issues. And the last but not least, to implement corrective actions to reduce RPN. So this ensures resources are used where they matter most. Think of as a triaging problem in the video game. We always want to fix the biggest threats first. So environmental considerations, we call it green design. Green design goal is to minimize environmental impact across the product life cycle. They choose to use in the safer material, designing for recycle, and efficient operation. And think of a backpack made of a durable and recyclable material. And they are good for both the customer and also for the planet. Okay, let's wrap up our lecture. The first insight we can get from this lecture is quality is design in. We need to start smart in the design stage to avoid costly mistakes. And second is customer focus is paramount. We can use Kano model and QFD to integrate real customer needs. And the quality design is a structured design process. Start from idea to production. It's a systematic approach to ensure efficiency. And it also involves integration and collaboration. DFM, concurrent engineering, and FMEA improve reliability and reduce costs. And last but not least, sustainability matters. Green design ensures responsible product development. So in summary, great products are not just built, they are designed, planned, and improved with the customer and the planet in mind.